All right. Welcome. It's the last day of Unit 1, you guys. Yeah, that's awesome. We've come a very long way, right? We started this journey 6 weeks ago. Think about how much ground we've covered in that amount of time. Quite a lot. Remember when things like, I don't know, functions and loops seemed kind of scary, and now they just seem a little bit scary, right? That's improvement, that's progress, and we still have a long way to go, but I think it's important to stop every once in a while and appreciate how far you've come as well. So congratulations on making it this far, and I'm looking forward to progressing through the next couple of units after we get a much needed break next week. We will still be here next week, but we're not having class next week. So if you get everything finished, you get all your assignments in for Unit 1, feel free to kick back and relax next week. Don't worry about coming in until the week after. If you need some help getting the last assignment or two in, then we'll still be here 5:30 on Monday and Thursday next week. So come on in, get some help. There'll be some TAs here. I will be here for at least one of those days. I'm not sure exactly which one yet, but I'm planning to come in for at least one of those days. And you can also reach out to us on Slack over next week as well. We'd be happy to help you out on Slack if you can't make it in. Let us know what you need so that we can give you that last push to get over the finish line and get you ready for Unit 2. Are there any questions about this transition from Unit 1 to Unit 2 before we hop into our final class of Unit 1? Any questions about what's coming up schedule-wise? No? We good? Yeah, so the question was if you come in during the break week, would you be able to ask about Unit 2? And the answer is absolutely. The TAs will be here, and they all know Unit 2 just as well as Unit 1, so you certainly could ask questions. The only thing that I might say is that if people need help with Unit 1, that's going to take higher priority because we want to get as many people across that finish line as we can. But absolutely, come on in and ask about Unit 2. Be happy to talk to you about it. Any other questions? Alrighty. Well, let's talk about today's material. We had one final chapter in the textbook. So who can explain to me what a mutator is? Anybody want to take a stab at that one? What a mutator is? Yeah.
A function outside of a class that affects what's happening inside.
A function outside of the class that affects what's happening inside of the class. Yeah, that sounds like a good definition to me. So what was an example that you remember from a text that they gave as an example of mutator? Cat and tiger?
Yeah, cat was your main part of what the cat does,
Mm-hmm.
and then tiger was the part where you were changing what the cat did.
Where we were changing what the cat did.
Yeah, because the tiger had a little bit different attributes, so they were adding like different attributes or methods.
So I think we might be talking a little bit about inheritance, right? Is that, or am I mixing up my definitions here?
They could be on mixing up mine.
Yeah, no, that's all right. That's all right. I do want to talk to you about cats. I mean, when don't I want to talk to you about cats? But that is a conversation that's on our list today. The definition that was given, though, is good. Something that modifies a class. And so, it's kind of related to this next definition as well. What's a helper function? We've actually seen this if you've started Visionaire crypto, we have some helper functions as well. What's that about? No? I'm sorry? Yeah, in the back. Yeah, so it's a function that you create just to help you complete another function, right? It's an additional layer of abstraction. This is actually a concept that's hard to hard to teach, hard to get across to students, but it's really important because what I tend to see is, first off, let's just go ahead and admit that functions can be a struggle, right? To get going. Like, let's not deny that fact. But so once people start to understand functions and want to use functions or methods in their code, what happens, or what I tend to see happening, is that they just start getting bigger and bigger and bigger and bigger because people just cram more stuff into those functions, when it might be better to break them up into smaller chunks. Might be better to break those down into smaller pieces. So that's kind of the idea behind a helper function, a function that we use to take a larger task and break it down into smaller parts. It relates back to a concept that we talked about a few weeks ago called composition, where I take a problem and I break it down into smaller pieces, solve those smaller pieces, and then compose those smaller pieces back into to solve the larger problem. Helper functions really used a lot for those kinds of purposes. And so the last question we see up here, actually maybe before we answer this question, we should take a second to review what's the difference between a function and a method. Talked about this a little bit on Monday, but it's good to review. What's the difference between a function and a method? Yeah.
A method is like inside a class.
Yep.
And it's basically just like a function, but a function is not in a class.
Yeah, so a method is inside of a class. That is absolutely correct. So think about what that means then. Can I use a method by itself? No. What do I need in order to use a method? An instance of an object. That's right. I need an instance of an object in order to use that method, right? I need an instance of an object in order to use that method. A function is not associated with a class. It's just there, right? It just exists. No instances required, no objects required to use a function. And so the question, we can get back to this question now. When is it okay to write a function instead of a method? So, I like to think of it in terms of examples. There are some things that are good examples of functions. We actually saw one. If you stuck around for the studio review at the end of last class, I introduced a function, actually, even though we were talking about objects. And there was a whole category of things that I think really fits with functions very well. It doesn't fit with methods very well. Does anybody know something that really, a category of problems that work really well with functions? Math. I'm doing mathematical things, taking a square root. The one we were looking at on Monday was, what was it, greatest common factor or something like that? Because we were talking about fractions at 8:30 on a Monday for some weird reason. Never again will that happen. That's not true. It'll happen next time I teach this class. But anyway, mathematical things translate very well to functions. They don't require objects. I just plug in the inputs and I get the output, right? So those are really common functions that you'll see. Not the only thing. I'm not saying you should only use functions for math, right? That's not what I'm implying. That's just one general category that works really well with functions. If I'm going to write a method, I have to think about how that method is going to interact with the object that it's associated with. Is it going to modify this object? Is it going to, what's it going to do in relation to the object? And so there's deeper implications to that as well, right? I don't have a concept of instance variables or fields with my functions because they're not associated with an object. So I can't use self, right? There's no self inside of a function. That doesn't exist. That's only for methods. So if you're thinking about a problem in those terms, or not, that can help lead you in the direction of a method or a function, respectively. I think one final point, and then I'll get off my soapbox about this. Just because we're learning about object-oriented programming and using objects for all kinds of things now, right, doesn't mean that functions should go away. Methods are not replacing functions. Functions still have their purpose. Functions are still a useful construct. We are going to be writing a lot more methods now, though. That's just a fact of the direction that we're headed in, since we're going to be using a lot more objects. But, keep functions in your back pocket for when you need them. Are there any questions about these things before we take a look at the next topic? All right, cool. What is shallow equality? What is shallow equality? I'm sorry? You're close. You're barking up the right tree. Yeah.
Not really sure about that. I mean, so when I think about quality, a list that has this in there. So no list, you have 3 elements in this list. Each element is another list. And I feel like shallow quality when you create I'm gonna stop there.
No, you're fine. Thank you for the attempt. I appreciate it. No, much appreciated. I think you could use lists as part of the definition, although I think we should maybe keep it more general and think about this in terms of objects, instances of objects. Yeah.
Is it just when two variables that have different names or something just are referencing the same object?
Bingo. Yeah, we got it. We got it. So shallow equality is when I have 2 references, or 2 variables, if you want to think about it that way, that are pointing to the exact same instance of an object. Remember, a variable, a reference, right? It's just a sign pointing to a specific instance of an object. So shallow equality is if I have multiple references, multiple signs pointing at the exact same instance of an object. How do we check for that? What does that look like in our code if I wanted to do a shallow equality check? Double equal sign is how we check for shallow equality. So if I have 2 variables, right, and I expect they're objects, right? I have 2 objects and I use double equals, it will return true if they're pointing at the exact same object. Now, this might sound a little weird, but that's not the only definition of equality. That's sort of the whole point of this line of questioning. There's another form of equality that's also useful to us called deep equality. So what is that? Yeah. Yeah, perfect. So I've got 2 objects, right? I've got 2 distinctly separate objects this time. But if I look at those objects, the values that they contain are exactly the same, right? That's what we call deep equality. So I've got 2 separate objects that are representing exactly the same thing. And how do I check for that? The is keyword, yeah, the is keyword in Python, I believe, is how we check for deep equality. And so, they're useful in different contexts, right? They're useful in different contexts. Think about, I'm trying to think, for example, if I've got a sock drawer, right, and I'm holding the sock in my hand and I need to find a match, that's an example of deep equality, right? Because I'm just looking for one that's got the same attributes. I don't need the same sock, right? Because I already got it, right? But in other cases, if I'm looking for, a person, right, a specific person, and you give me another person with the same name, that's no good to me, right? It kind of looks like they're the same at a deep level because the name attribute is the same. They have the same name. But I'm looking for one specific person, right? So that's an example of shallow equality. Does that make sense? Hopefully. So they're both useful. One is not necessarily better than the other. I think what's important to understand here is that there are multiple ways of measuring equality, and there are multiple ways that we can check for that in our code. Does anybody have any questions about that? Alrighty. So last but certainly not least, I want to talk to you about inheritance. And so before we get to this question, recall Monday's discussion, we actually defined relationships between classes and the 2 kinds of things that they contain, right? So if I'm describing the relationship between a class and the variables that it contains, what's that relationship? I say this object blank, this variable. Said it out loud in a sentence last time when we were doing design. We made two lists, right? Has a, yeah, that's what I'm looking for. The relationship between an object and its variables, right, is has a. So cat has a tail, cat has fur. That's what we did in Monday's class, right? And then the behaviors, what's the relationship between an object and its behaviors? It's what they can do, right? That's what I would say. So now we've got this new kind of construct that I want to talk to you about called inheritance. And so the question is, what's the relationship if I have two objects that are using inheritance? How would I describe that relationship? So we saw the example in the book, somebody brought this up earlier, of cat and tiger, right? What's the relationship? Cat blank tiger. Are like? Close. Is a, yeah. A tiger is a cat, right? A tiger is a cat. So if I'm trying to distinguish, or if I'm trying to determine an inheritance relationship between two objects, I'm going to consider that an is a relationship. So, you know, another classic example of that would be vehicles. I can have a vehicle class, and then I could say, you know, a boat is a vehicle, a car is a vehicle, a plane is a vehicle, right? Or shapes. I could have a shape class and then say square is a shape, triangle is a shape, rectangle is a shape. Those are classic examples of inheritance relationships. And so last but certainly not least, why? What's the point? Why do we use inheritance? What's the advantage? Yeah, go ahead.
Well, instead of like describing your cat and then redescribing your tiger, you just describe the things that are different. Mm-hmm. Or add.
Yeah, perfect. So it allows me to reuse code. It allows me to reuse code. So in the situation of cat and tiger, right? I've got my cat class and I've got my tiger class, and I have inheritance between them. We have more technical terms for those classes, right? I'd say that the cat is what kind of a class? A superclass. Or other terms you might hear for it would be a base class, right? There are other ones, but my mind is kind of drawing a blank right now. A superclass or a base class, and then the tiger class we would call a subclass. You might hear it called a derived class, for example. For whatever reason, computer scientists like to have multiple names for the same thing. So that's just another example. But you know, superclass, subclass relationship. And so, which direction is the inheritance going? What inherits from who? The subclass inherits everything that's in the superclass. So I inherit methods, right? Do I inherit variables? Sure do. I get it all. I get all of them. I get the methods, I get the variables. Those all exist in the subclass without me having to do anything except tell it that I want that inheritance relationship to exist. And so then all that's left for me to do in the subclass is describe anything that's different. So what makes a tiger unique, right? Yes, a tiger is a cat, but a tiger is, you know, still distinct from other types of cats. And so now I just describe what makes a tiger unique in this class. I can make a lion class. Lion is a tiger, or lion is a cat. Or I can make a house cat class and then describe what makes those individual entities unique while still keeping the similar behavior in the superclass, in the base class. Does that make sense? It's a very powerful tool, one of the most important object-oriented programming concepts. And I should add a classic interview question as well. Interviewers love to ask people about inheritance. So just throwing that one out there. Does anybody have any questions before we start today's walkthrough? No? We good? Yeah, go ahead. I'm sorry, I can't quite hear you. I'm sorry, I still couldn't quite hear you. Could something inherit from the superclass? I'm not sure. Can you restrict what's inherited from the superclass? Is that the question? That's a very good question, and I know what the answer is in some other languages, but I'm struggling to remember what the answer is in Python. I think the answer is probably yes. You can restrict what gets inherited, but you can.
Inside the method, where you have to call super to actually. If like if you write the same function with the same name on the parent class, you don't call super, but when you run the code,
it will override the function. Yes, you can override functions by creating a function with the same name. That is correct. But could we prevent that function from even coming down at all, I guess is the question, or it might be more appropriate to talk about variables, right? Could I restrict what variables get passed along to the subclass? Again, I feel like the answer is probably yes, but you can tell by the way that I'm talking about it that I'm not 100% certain. Let's take a peek. Let's take a peek and see. So what would I Google? Python restrict inheritance? I don't know. Just as a starter, let's see. Let's see if we get anything good coming back from that. Is there any way I can yeah, perfect. Nailed it. Sort of, but don't do it. That's a great answer. I like that answer. Yeah. Perfect. Okay. That made my day. I'm really glad I decided to Google that. There you go. That's as good of an answer as I could have possibly hoped for. Are there any other questions? Yeah.
So again, phrase as well. In the inheritance chapter, section of that chapter, it goes to tiger and it inherits everything from cat, and then the next one is the house cat, which initializes itself. And then it goes cat dot initialization parentheses self. So the tiger didn't do that. The tiger didn't initially go cat dot initialization. I wonder why it didn't make more sense.
I think I understand what you're talking about, but if you don't mind, I'm going to take a second just to look it up real quick and make sure that I understand exactly what you're saying before I try to take a stab at an answer on this one. So let me just pull up the chapter real quick. Probably faster to go to the table of contents.
I believe it was because house cats have names and cat class don't name them.
Because house cats have names in the cat class.
So that seems like pretty arbitrary.
Well, let me take a peek here real quick. In the inheritance chapter, you said, right? All right.
Another class cat subclass.
A naive tiger, a better tiger. Oops.
So when they define class tiger, they didn't start with the init.
Yeah, you can see tiger doesn't have a constructor at all, right? And so what does that imply? I don't see a constructor here. What does that mean? That means that, what's the role of the constructor again? Make sure all of the variables are defined, right? The constructor's job is to make sure that all of the class variables get a value before it's finished. And so what it means that there's not one here implies that the tiger does not need any additional class variables that it's not already getting from the cat class. That's what it's implying. But it's possible that I have a subclass that does want to have an extra variable. In this case, I want to add a name variable to my cat class. So I'm getting the two variables from the base class, from the superclass, right? But I want to add a third variable to my subclass. So I call the constructor on my base class. That takes care of those two variables, but I still am on the hook for the third one that I want to add. And so you can see that I do that here. Does that make sense? Yeah, it's a great question, actually. I'm glad you brought that up. Because that's part of the strength of inheritance, right? Is you see it right here. I'm reusing code that I already have in my superclass. I don't have to redo this stuff in the constructor. I can just use the existing constructor. There we go. And then I can add on anything that's different. In this case, just the additional variable. Great question. Any other questions? Yeah, what's up? Can you make a subclass of a subclass? Absolutely, you can. Yeah, we would call that a hierarchy. So there can be an inheritance hierarchy where I just chain together classes. Absolutely, you can. There are things that you kind of need to pay attention to a little bit. That some issues where you can get into trouble, but I guess we'll stay away from those for now. I mean, so here's another question for you. Can I inherit from more than one class? Can I make a subclass that inherits from more than one class? I'm sorry? I think I heard both answers, yes and no. Yes? No? Yes? Python, multiple inheritance. Multiple inheritance. Looks like the answer is in fact yes, but the problem with multiple inheritance, with inheriting from multiple classes, you run into wow, that's a lot of code, holy moly. You run into the diamond problem where I've got a class that inherits from two classes and those classes both inherit from this same class. But what if the code from this class conflicts with one of these two classes? What if I have conflicting methods in those classes? Then which one do I pick? Which one do I use? So we're getting far down the path here. I know this is not something that was covered in the textbook, but just going off on a little tangent there for a second, I suppose. Great questions. Any other questions? Any other inheritance questions? We've actually just scratched the surface of inheritance. There's a lot of stuff that it can do that we didn't quite get to in the textbook, but this is not the last time we're going to see inheritance and talk about inheritance in this class, so we're just going to stick with the basics for today. If there aren't any questions, then we can do the walkthrough for today. Did I close the walkthrough window? Whoops, I guess I did. Didn't mean to do that. Huh. Okay, I guess I closed it. My bad. All right. I want to go to class, where is it? Class 12. I'm going to ask you all to avert your eyes for a second as I delete the solution so we can start fresh. Whatever. We're all adults. I am going to delete everything though from here on up because I want to write it myself. And so today's walkthrough, it is based around inheritance, but I think it's also important to note that we're going to introduce you to a class diagram today as well. So a class diagram is a way of visually describing our classes. On Monday, when we did the design exercise and we listed out all of the attributes and we listed out all of the behaviors that we wanted, that was a very informal way of making a class diagram. We're actually going to take that a step farther today and turn it into a formalized way of talking about our classes and how they relate to each other. The end goal of the design phase of your program is usually to generate a class diagram. And that class diagram is going to explain every class that your program needs in order to function, as well as all of the attributes and all of the methods that those classes should contain. And the idea behind doing that is that once you have such a class diagram, you then know exactly what to put in your code. There's no more guesswork involved. What do I need to add in this class? I need to put these attributes and these methods, right? I'm making it sound a little bit simpler than it is, but we're trying to separate the design process from the implementation process. Because what happens a lot of times, and I've seen it in this class too, is you got a problem you want to solve, so what do? You just sit down and you start banging on the keyboard, right? And for the stuff we've been doing so far, that probably works out okay. But as our programs get larger and larger and more complex, and they have more pieces that need to interact with each other, that's not going to work out as great for you if you just sit down and start banging out code without having a plan. So we're trying to get you in the habit of thinking about your design first, getting some ideas down on paper. Don't even think about code right away. Just think of the design piece, and then once you have a well thought out design, you can turn that into code. Should hopefully reduce the amount of times you get stuck along the way. And so we're going to present you with a very simple class diagram, and then we're going to implement it. That's the walkthrough for today. And then you're going to repeat that process for the studio. We're going to present you with another class diagram in the studio, and then you're going to implement those classes in the studio today. So a class diagram includes the stuff that you would expect. The name of the class, the methods, the fields, and then we can represent inheritance by drawing an arrow from one class to another class. So the arrow is pointing at the superclass. Comes from the subclass to the superclass is the way that we traditionally write those arrows. And these are all actually defined as a standard called UML, Universal Modeling Language. And so here's an example of what this looks like for today's walkthrough. I've got two classes, a post class and a video post class. We're making a blog. We're making a little blog today, and you're going to extend the blog functionality actually in Studio today as well. And so you can see the methods that I expect my post class to include. I've got a constructor, and you see I've even listed out the parameters, right? I've got a method for liking a post. I've got a method for creating a string version of my post, right? And then here are the attributes that I have: author, title, body, and likes. And then I've got another class down here for a video post, and you can see that because there's an arrow between the two, it's inheriting from the post class. So a video post is a post, right? And if I say that out loud, it makes sense. It seems like a reasonable relationship between those two classes. And you can see the methods and the attributes, the fields that this video post class has. And so with this diagram, it should be hopefully relatively straightforward for us to implement these two classes. And that's what we're going to do. We're going to start from scratch and implement these guys. It makes sense to start with the superclass, right? Usually makes sense to start with the superclass. So I'm going to start with the post class. I'm going to come down here, and today's walkthrough is going to be a little annoying because I'm going to keep scrolling up and down to refer to the diagram, but that's part of the process. So let's go ahead and get started. We're going to create a post class, and we'll just go down the list. The first thing that it suggests that the first thing on our list of methods is the constructor, which, spoiler alert, is probably almost always going to be the first thing that's on the list of methods, is some kind of a constructor. So let's go ahead and make that. So not only do we have a constructor, but it's even telling us what the parameters of the constructor should be. But you might notice something, right? The constructor has, besides self, it has 1, 2, 3 parameters, and you can see that those match up pretty well with the parameters that we have down here. But I've got one additional parameter, likes, that is not included on this list. So what does that mean? What is that telling us? What is it telling us about that field? It should be initialized to some constant value, right? Remember, there's multiple ways I can set a field. I can accept it as a parameter to my constructor, or maybe it just has some constant value. So when I create a post for the first time, if I go onto Facebook and post something right now, how many likes does it have? 0. So I'm just going to set it to be 0 every time. And then when my grandma reads it, it'll have 1 like. And that's probably where it'll stop. Just kidding. My mom will like it too. But for the other ones, we'll take them in as parameters. So we've got title, author, and what was the last one? Body. Okay? And so I can go ahead and set these. You see the attributes here. Remember, the role of the constructor is to set the values for each of its fields. So I'll do that for the ones that have been passed in as arguments. And then I'm left with the one remaining field that we talked about, the likes, and we just said that that's going to be, set to a constant value of 0. And now my constructor has done its job. It has made sure that all of the fields that are part of this class have been initialized to some value. right? Any questions so far? Okay. So we've already covered a big chunk of this, just a big chunk of this diagram. The diagram is suggesting that we have another method called like. So I assume that's what's going to happen when somebody clicks the like button on my post, right? So I think it's going to be a pretty straightforward method. Oops, def, like. The input parameter was given to us already as just self. Excuse me. So this method, what do I need to do to implement this? I think it's just a one-liner. Self.likes plus equals 1, sure. Just add 1 to the number of likes on the post. Yeah, what's up? That was my next question. You beat me to the punch. Would this like definition be considered a mutator? What do we think? What do we think? You seem very confident. Yes, it is. Because it's modifying one of the attributes of my class. It's a mutator. Yes, exactly right. And so we've got one more to go. We've got this string function, which we know what that is supposed to do. It's just supposed to create a string representation of our post, right? And so we can make that next. And again, these are also typically one-liners. Oops. Self. There we go. All right. So I just need to turn this into a string, right? So I'll say print parentheses. And then what do I need to start doing? Decide what's important to print out. Okay, so what's important to print out? Could say everything, right? Is there a problem? You just want to know the number of likes? That's all you care about? You don't want to know which posts is getting the likes so that you can know what more posts you should be making, right? I mean, we can just put everything in there, right? It's not hard to do. So, you know, title plus. It's a little tedious to type it all out, but it's not too bad. And then we've got the body. Oops. And then the likes. Okay. I need a plus, thank you. All right. So we've implemented everything that the spec asked us for so far. And so, you know, we have another class to go, but let's just test. Let's just test where we're at and make sure that it works. We've already got some tests down here, although I'm going to temporarily comment out the stuff with the video post because we don't have a video post, so that's not going to work, right? But I can check everything else. I can check everything else that I've got with the plain post. So I should be able to create a post and print it out and see what it's got. Notice there aren't any likes here. That's kind of sad. Maybe we should change that. I don't know. But let's just run it and see what happens. Uh-oh. Cannot concatenate string and int objects. All right, so one of my properties is an int. Oh yeah, the likes is an int. So I need to make sure that gets turned into a string. Oops. All right, let's try it again. Title, there's the title, there's the author, there's the body, dot. What? Is that what was on there? Oh, okay. Yeah, they just didn't want to put out, okay, yeah, I got it. I got you. 0 likes, boo. And then, oh shoot, we got an error. Yeah, I was waiting for somebody to call me on it. There it is. We need to return a string, not print a string. Return. Whoops. All right, I think I got my tabs or something screwed up here. Let me just... Oh, my parentheses. Thank you. I got that extra one. Thank you. All right. I think we're okay now. Cool. Yeah. There we go. Yeah, what's up? Yeah.
Sometimes, like in this instance, we have to plus sign.
Uh-huh.
And sometimes I see it as a comma.
Okay. So the question is, sometimes we see plus sign here and sometimes we see commas in between here. Actually, I almost always use the plus sign, and there's a good reason. What does it mean if I use a comma here? You want a space? It inserts a space, I guess? I mean, but what's the bigger implication there? In print functions, yeah, I think I would agree with you. I see it more in print functions as well. Does anybody know what the actual difference is, though, when you do tuples? Yeah, commas. We saw that with tuples. So that really heavily implies that I'm actually making a tuple here. And when I print it out, it doesn't look that much different, but it's actually a tuple, right? And so it gets printed out, and I can see that it looks kind of like a tuple, and so you see some artifacts of that. If you're trying to stick things together, I think concatenation is always the way to go, in my personal opinion. There's no reason for this to be a tuple, right? I just need to return one string with the information in it. There's no reason for it to be a tuple. Is it hurting anything? Maybe not. But there's no reason for it to be a tuple. I got a little bit of formatting errors, I guess, in this one, but it looks pretty good. Looks pretty good. All right, any questions on this before we do our second class? All right, so we got one more class to go. It's a video post, and so I want to take a look, right? I see it's using inheritance here. It's using inheritance, and so I'm asking for a constructor, and you can see the reason why, right? You can see the reason why. I've got a URL involved with this. So I've got an additional parameter. Actually, I've got an additional field. I've actually got two additional fields. I've also got this plays, or you could call it watches. How many times has somebody watched this video, right? So I do have some additional fields that are being added. So I get all of these fields, but then I'm adding a couple of additional ones on as well. And so that means that we do need to define a constructor for this class. But before we do that, let's define our class. Class video post. And then how do I signify that I'm using inheritance here? Parentheses, and then the class that I'm inheriting from, which is post. All right, and then we'll go ahead and make our constructor. And you can see that they gave us the parameters: self, title, author, URL. Okay. Self, title, author, URL. What should I do first? What should I do first here?
You can get title and author from. You don't have to redefine.
So title and author come from my other one, right? So is there an easy way for me to do that? Yeah. Post.init. So call the constructor of the post class, right? Call the constructor of the post class. Post dot underscore underscore init. But then I have to provide the title, the author, which I have those, right? I'm just taking these values and passing them to the constructor of the post. But we do have one small issue. The post expects a body, And I don't have one of those. So how should I treat this? Anybody have any ideas? Anybody have any ideas? None? I heard two ideas. None was one idea that I heard, or an empty string was another idea that I heard. Does one of those seem better than the other? I think they're both probably somewhat viable. If I do think I slightly prefer an empty string here, if only because I'm a big stickler on this. By the time the constructor is over, every single field should have a value, and none is not a value. I don't like having fields that are labeled as none after the constructor has completed. So I understand why you said none there. In fact, if you used none here, I probably wouldn't be that upset about it. I'd probably be okay with it, but I do prefer an empty string, if only because at least that's something that exists. It's a value. It's not none. And I would much prefer to have my fields with some value, not just none. So we can try it both ways. I mean, if we have time, we can try it both ways and see how that changes things. I forgot some underscores, didn't I? There we go. Why not self? Anybody know? Why not self? Yeah.
Host is self.
Host is self. Do we ever pass self in? You ever see that passed in? Like, we put self here in all of these, right? But we never actually pass in a value for that, correct? Because where does it come from? Like, for example, we didn't do this, but we could. What if I wanted to add a like to this post? How would I do that? How would I add a like to this plain post that I've got? Plain post dot like. Empty parentheses. So you notice I didn't put anything in here. So what is it? Where does it come from? Implied. I mean, yeah, but it's also on the screen, on this line. It's whatever's to the left of the dot. That is self. That is self. I don't have to put it in the parentheses. Whatever is to the left of this dot, the instance that I'm calling the method on, that is self. And so here, you know, it's just going to be a post, right? For the constructor, it's just a post. Or whatever the object is that you're creating. Good question, though. Great question. All right, so I've covered all of the fields from the post class, but I still have a couple of additional fields from the video post class that I'm still obligated to handle. I have a video URL and plays, right? So the URL looks like it came in as a parameter, so that one is pretty straightforward. Self.video URL equals URL. And then plays, it didn't come in as a parameter, so again, what's that telling me? Starts at 0, right? First time I created, nobody's watched it yet, so self.plays equals 0. And now, again, just to make it clear, this constructor is responsible for making sure all of the variables have a value, including the ones that it inherits from the post class. And we have accomplished that, right? Calling the post constructor takes care of all of the post fields, and then we have taken care of the additional 2 fields for the video post. Question, yeah?
Did you ever call like a instance of an initialization anywhere else but this inside another initialization?
Would I ever do this anywhere else besides inside of a constructor? Unlikely. I don't like saying never, because computer science always has a way of sneaking around the rules, but I'd say very unlikely that you would do this anywhere else. Great question, though. Yes, another question. Yes, that is correct. So even though I have title and author here, I mean, when I call the post constructor, I have to supply it with those values. So where do I get those values from? Well, I'm getting them from the video post constructor, and then I'm just passing them along. Yeah, that's what's happening. Great observation. Yeah, in the back. I'm sorry, you mean here? Do I have to include the self parameter? I believe that's what we just discussed, right? Self comes from whatever's on the left side of the, yeah. It really? Well, perhaps I am mistaken then. Really? Okay. Oh, you're right. It even says I should have just scrolled down a little bit, huh? Actually, yeah, and this is actually unfortunate because of the textbook. I've run into this exact problem before. I run into it every time I teach this class, and I just didn't read far enough ahead this time, unfortunately. Thank you for reminding me about that. You are correct. We do need self here just because this is a little bit of textbook. The way that the textbook works, unfortunately, is forcing us to do things this way. Sorry about that, guys. In the general case, it's a little unfortunate, actually, that the textbook does require us to do it this way, because once we stop using the textbook, which is like today, we won't be using this particular form anymore. We'll be using this form, and you can see that there is no self here, which is why it's a little confusing, and I apologize for that, but that's just an unfortunate side effect of the way that the textbook is set up to run Python. Yep. Any other questions? Yeah, what's up? Okay, so if line 18 was gone, what would happen? Does anybody know? Yeah. So it would never run the parent constructor, which means that this video post class would have these fields, title, author, body, and likes, but they would all be empty. They would all be none because they have never gotten set. And that, to me, is really bad, right? The role of a constructor is to make sure that those have values. Yeah, great question. Any other questions before we start putting together the rest of this class? Yeah, what's up?
So if you were to comment out this entire initialized block, then would it just automatically run the constructor from the post?
Yeah, great question. So if I don't have a constructor here, then yes, you are correct. It's just going to use whatever this constructor is, but that means I am now just stuck with these 4 fields, and I do not have the additional fields that I want. So if I'm using inheritance and I don't need these additional fields, then you don't have to make a constructor. You're off the hook on that one. You can just use the constructor that you're inheriting from the superclass. It's very straightforward. But if I need to add additional fields, then I have to make a constructor in my subclass to accommodate those additional fields that are being added. All right, so we've got a play method and a string method, which, you know, behave very similarly to the ones that we saw in the post class. So we can whip those up real quick. Def play. This is just going to increment the plays by 1. So very straightforward. And then last but certainly not least, we've got the string. And so one thing that I could do, right, is I could, you know, list out, we have 6 fields now, right? I could list out all 6 fields. Can anybody think of an easier way? Can I start by calling this one? That takes care of those 4, and then I just have to add the additional 2 on? How do I do that? Post.string, and then I think we probably have to put self in here. I think. We might have to experiment with that a little bit just to see. And then I just have to concatenate now the other ones, which are the URL and the plays. Oh, video URL, thank you. I'm not 100% certain that this will work, but I mean, I feel like it's got a pretty good chance anyway. We'll see. See what happens. And so we're ready to test. I can come down here and uncomment these lines that I had commented out previously. Do I need to turn what in? I'm sorry? Oh, I do. I need to wrap that. Thank you. I would have found that out sooner or later. But yes, you are correct. All right. So now we're making a video post, right? Notice that when I construct my video post, I'm just passing in the title, the author, and the URL, right? Because that's all the video post constructor says that it wants, are those things. It goes to the post constructor, takes care of those variables, adds on the additional ones that I asked for. This time we're going to call the play one a couple times. We actually called like as well, so we can see if those methods are working properly. So let's give it a go. Let's see what happens. All right. 2 plays and 1 like. And it looks like the URL worked. It looks like our string method worked perfectly, right? It's trying to return body, and you can see it's empty. That's a little unfortunate. It's accurate, though, right? I mean, it's an accurate representation. Let's switch it to none and see what happened there. Oops. I don't think it's going to break anything, but I don't know. Let's find out. It might. Okay, yeah. It did. Can I fix that? I don't know that I can fix that. I mean, so there you go. If you're deciding which way to go, in this particular case, that sort of makes the decision for us, right? Using none here is not the way to go. So an empty string is okay, or you could, I mean, if you really wanted to, you could just put like no body, right, or something, if you really wanted to. Or none in quotes, yeah, sure, right? The string none, yeah. I really don't like having, none as a value being passed into a constructor. That to me is a big red flag whenever I see it. That means I'm basically telling the constructor it doesn't have to do its job. So I prefer this way. NA, sure, yeah, lots of things you could do. Any questions about this exercise? Yeah. Okay. Okay, we take this out. Here? Okay. That's actually a good question. I don't know the answer. I'm curious, so let's try it and see. If I had to guess, and this is a guess, so I could be wrong. If I had to guess, it would, give me a similar error to what would happen if I took this out, if I had to guess. But let's just see. Let's see what happens. Yeah, that's what happened. It's expecting exactly one argument. If we were doing this in a proper environment, it would look like this, and that would work. Yes, that would work. Unfortunately, the book does not recognize that statement, so that's why we are having to run this alternative version. And there we go. So that way works. Perfect. Chris Bay, by the way, is our, he's on Launch Code staff here. He helps develop a lot of these courses and likes to listen to hipster music, apparently. I don't know what this band is, but he's a big music snob, and I don't think he'd even be that upset that I called him a music snob. So, Chris, if you're watching this video, I love you, man. You're great. I don't know what this is, though. Maybe it's good. Any other questions? All right. That was our last walkthrough of Unit 1. You got one more studio left and some assignments to submit. So I'm going to turn you loose, and we'll meet up for the last studio review session of Unit 1 at around 8 o'clock. Thanks, everybody.